Yes. Good morning, students. Is the screen visible? Okay. So today's topic, we are going to discuss this about amines. Okay. So what are amines? So these are important class of organic compounds, right? Which are derived by replacing one or more hydrogen atoms of ammonia molecule by alkyl or aryl groups. Okay, so you know what is amine. So how do you represent your amine? RNH2, right? RNH2. You represent your amine as RNH2, like this, right? So replacement of your, it is an ammonia derivative. It is a organic compound which is formed from ammonia molecule. Okay, that is replacement of one or more hydrogen atoms of ammonia. It comprise of amines. So these amines can be considered as what? They are considered as the derivative of ammonia. How they are obtained? They are obtained by replacement of one, two, or all the three hydrogen atoms by alkyl or a aryl group. Okay, so these are the examples for your amine. So you can see here. So first is methanamine. Okay, this is benzylamide. So right, so this is dimethylamide. So like this, these are the, so you can see here only one of the hydrogen atom is been replaced by CH3 group, right? Then your one hydrogen atom is been replaced by your aryl group, right? So your two hydrogen atoms are replaced by your alkyl group. So in this, all the three hydrogen atoms are being replaced in your by your alkyl group. So these are the examples for your amine. So what are these? These are the derivatives of ammonia. So how do you obtain it? It is obtained by the replacement of one, two, or all the three hydrogen atoms. Okay. So this is amines. So what is the structure of amine? So when we are discussing about the structure, so like ammonia, you know ammonia, how it is, how is the ammonia structure? So like ammonia, nitrogen atom of amines is trivalent, okay, and it also contains what? Unshared pair of electrons. So this nitrogen orbitals in amines, it is having sp3 hybridized, and the geometry of the amine is trigonal pyramidal. So you can see the diagram, right? So it is a pyramidal shape of trimethylamine. So it is trimethylamine. So a nitrogen in the center. Okay, and it has a lone pair of electrons. So this is unshared pair of electrons. So because of the unshared pair of electrons, the angle between the C and E, okay, angle between the C and E, that is carbon nitrogen angle, it is less than that of 109.5, because lone pair bond pair repulsion is more than bond pair repulsion. So as there is a lone pair, unshared pair of electron present, so the angle is less than 109.5. So what is the geometry of amines? It is trigonal pyramidal. Okay. So next is classification. So amines are classified as primary, secondary, and tertiary depending upon the number of hydrogen atoms which are replaced by alkyl or aryl. So if one hydrogen atom has been replaced, then it is said to be what? Primary amine. If two hydrogen atoms of ammonia are replaced, then it is called as secondary amine. And if it is all the three hydrogen atoms are replaced, then they are called as tertiary amine. Okay, so these are the classifications of amine. So either the hydrogen atoms can be replaced by alkyl group or a aryl group. So here you can see at the bottom, okay, so primary amine, secondary amine, and tertiary amine, how it is represented, right? So first is ammonia molecule, second is primary amine, so then is secondary amine, and the tertiary amine. Okay, next is nomenclature. How do you name it? Okay, so whenever you're in common system, an aliphatic amine is named by prefix alkyl group to amine. Okay, that is alkylamine. So it is called as alkyl amine as one word in common system. But we make use of what? It is IUPAC system. So whenever if in common system, if you have more than this, okay, if you have two or more groups of amine present, then you have to represent as the prefix di or tri is used, okay, in before the name of the alkyl group. And in case of IUPAC system, your amines are named as what? Alkylamines. Okay, it is named as alkanamines. So that is what is from the, it is derived by replacement of E. Alkane E is replaced by your amine. So for example, CH3NH2, it is named as what? It is named as methanamine. Okay, it is named as methanamine. So in case more than one amino group is present at different position in the parent chain, then the positions are specified by giving numbers to the carbon atoms bearing NH2 group, such as the prefix used as di, tri, okay, it is attached to the amine. So based on the number of carbon atoms, okay, bearing the NH2 group, you have to number the chain. Okay, and then based upon the number of NH2 groups, you have to give the prefixes di, tri, etc. Okay, so for example, see, you can see this example. What is the name? It is ethane 1,2-diamine. So it is one position. This is second position. So it is ethane 1,2-diamine. So in case of aryl amines, okay, in case of aryl amines, if NH2 group is directly attached to benzene ring, aryl amines means what? Aryl means a benzene ring, a aromatic ring, right? So if a NH2 group is directly attached to a benzene ring, for example, C6H5NH2, the simplest example of an aryl amine, the name is aniline. Okay, it is aniline. So when you write the aryl amine, so according to IUPAC system, the suffix E of arene is replaced by amine. So what is the name? It will be benzenamine. Okay, it is benzenamine. So this is the nomenclature of amine. So we'll see. Now we'll go for the so now we'll go for the preparations of amines. So we'll see the preparations of amines. So first is Gabriel thalamide synthesis. Okay, what do you mean by Gabriel thalamide synthesis? So you can see here Gabriel thalamide synthesis. The starting reactant taken is thalamide. Okay, it is a thalamide. So you can see C double bond O NH. Okay, NH. C double bond O is a thalamide. Okay, it is a amide group, amide. So Gabriel thalamide synthesis. So first reactant is your thalamide. So thalamide is treated with a alcoholic KOH. Okay, a alcoholic KOH, that is a base. So and what happens here? Your hydrogen, it is an acidic hydrogen. So this acidic hydrogen get replaced by your potassium salt, right? This potassium salt K. So it is replaced, this acidic hydrogen is been replaced by your K. Okay, it becomes what? It becomes potassium thalamide. Okay, it becomes potassium thalamide. So it forms its salt. It forms its potassium salt, right? So this is a potassium salt, what it is forming. So you can see this is a potassium thalamides, right? So your hydrogen, active hydrogen is been replaced by your potassium. So this becomes a potassium thalamide. It is a salt. So then you treat this potassium thalamide with what? With your alkyl halide. Okay, alkyl halide, you get what is only the reactive site is your this. Okay, so at this position, what happens? Your alkyl group. Okay, your alkyl group get replaced. Okay, and with the release of kx, with the release of your kx, okay, so it leaves behind kx and your r, okay, your alkyl groups get attached to this thalamide compound. So n alkyl thalamide is obtained. Okay, n alkyl thalamide is obtained. Further, you treat this with NaOH. You treat it with a strong base NaOH, which is in aqueous medium. Okay, what happens? Okay, so your so at this particular bond, okay, this bond breaks. So this bond breaks, and what it forms? COONA, Na plus. Okay, COONA. So this is a carboxylate salt is formed. Okay, a salt is formed here. So plus a one aliphatic acid. Okay, that is a primary aliphatic amine is formed. So this is Gabriel thalamide synthesis, wherein you are going to prepare your primary aliphatic amine from a amide. From your amide, you are going to prepare your amide. Okay, so this is a what this is. So from amide, your synthesizes your amine. Okay, a primary aliphatic amine. So this is the process. So from thalamide, you are going to synthesize your primary aliphatic amine. So this is Gabriel thalamide synthesis, one of the important synthesis of amine. Okay, preparation of amine. So next we'll go for Hoffman bromamide reaction. So this is also one of the important name reaction. So this method, where it is used, this method is used for converting amides, okay, amides to primary amines. Here, what happens, you can see in the starting reactant, okay, starting reactant, you have 2 carbons. In the product, you have only 1 carbon. So this reaction, Hoffman bromamide reaction, it is a, you can see there is 1 carbon less. Okay, 1 carbon atom is less as compared to your reactant. Okay, it is a degradation reaction where wherein you can see that the number of carbon atoms. So here there are 2 carbon atoms. It is been less by 1 carbon atom. So this is used for converting your amides to primary amines. So here the reaction taken is as of acetamide. So this is acetamide. CH3, C double bond O, NH2. Okay, so this you treat it with what? This you treat with Br2, bromine. Okay, in KOH, alcoholic KOH. What you get is methanamine. You get a methanamine plus potassium carbonate plus potassium bromide plus water. Okay, so this is Hoffman bromamide reaction. This is Hoffman bromamide reaction. Okay, Hoffman bromamide reaction wherein you are converting your amides to primary amines. Okay, so what is the reagent? So remember what is the reagent? It is Br2 in alcoholic KOH. It is Br2 in alcoholic KOH. Okay, and the number. So the reactant, if it has 2 carbon atoms in your product, you will yield only 1 carbon atom. Okay, there will be 1 carbon atom less. Next is reduction. Okay, you are going to do reduction of nitrogen containing compounds. So what is a nitrogen containing compounds? So your first is nitroethane. So the this is taken as nitroethane. Your reactant is your nitroethane. So you can see nitroethane. It is treated with tin HCl. Okay, it is treated with tin HCl. So this is a good reducing agent. So it is acting as a good reducing agent. Okay, or the catalyst uses H2. Okay, H2 with platinum. Okay, H2 is platinum. So these both are a good reducing agent. So what you're going to do, you're reducing your nitro group to your amine group. Okay, so ethanamine, ethanamine. So reduction of nitro containing compound using. So first is with tin and HCl. Okay, you yield your nitro group is reduced to NH2. Next is ethyl cyanide. Okay, lithium aluminum hydride is also a good reducing agent. It is a good reducing agent. Okay, so it is very expensive. Lithium aluminum hydride, the reagent is very expensive. So ethyl cyanide. So this is your cyanide group. So what happens here? Ethyl cyanide using your lithium aluminum hydride, you can see you yield propanamine. Okay, addition of hydrogen is nothing but your reduction. So you're going to add there is the addition of hydrogen. Okay, so what is it? It is propanamine. So the product obtained is propanamide. So next is ethanamide. Okay, from amide using lithium aluminum hydride, you're going to prepare your amine. So you're going to reduce it. So amides. Okay, so what happens here? CO group. Okay, that is a carbonyl group using your lithium aluminum hydride is converted into CH2. It is converted into what? It is converted into CH2. So there is what? Removal of oxygen atom, right? Addition of hydrogen. So it is reduction. So these are the reagents, specific reagents which are used for reduction of nitrogen containing compounds. Okay, remember the reagents which are used here. So next. So we'll solve questions based on this. So an organic compound A, upon reacting with NH3 gives B. Okay, on heating B gives C. C in presence of KOH, potassium hydroxide reacts with Br2 to give CH3, CH2, NH2. What is A here? Yes, what is A? What is A? Here? Yes, A is the answer. Yes, A is the answer. Damini, yes. Kumar, yes. A is the answer. So we'll see the reaction. So the organic compound is CH3, CH2, COOH. So what they have done, they have treated this with NH3. They have treated it with ammonia. Okay, this is what? This is propanoic acid. So this is propanoic acid. So propanoic acid is treated with ammonia. So what happens here? So CH3, CH2, COO. Okay, and NH3 forms NH4. Okay, so so addition of here. So NH3 is added across this double bond. Then this forms what? This is ammonium propanoate. Okay, propanoate. So this is ammonia propanoate. So this further is what? It is heated. Heated. Okay. So after heating, what will happen? Water molecule will be released, right? So it forming CH3, CH2. Then this is CONH2. Okay. So this is propanamide. Propanamide. Okay. So this propanamide further. So this is a compound C. So this C compound is further treated with what? Br2 plus KOH. So Br2 plus KOH, this is what? Hoffman bromamide reaction, right? Hoffman bromamide reaction, what it gives you? What happens in Hoffman bromamide reaction? One carbon will be less. So it is CH3, CH2, NH2, right? So this is the method of solving this particular question. Okay. So this is a method of solving this particular question. So like this, you are going to solve. So the organic compound A is your propanoic acid. Okay, it is propanoic acid. So we'll go for the next one. Which of the following compounds is formed when benzamide is warmed with bromine and alkali? Yes. Yes, go through the options and try to solve it. No, not A. Yes, Tarun. Yes. So it is C. So how it is C? We'll see the answer. So what it is given? Which of the following compound is formed when benzamide? So how do we write benzanamide? Okay, benzanamide. How do you write? So this is benzene, C double bond O, NH2. So this is benzanamide. So this is the amide group, right? So benzanamide is treated with what? Your bromine water, bromine in presence of KOH, right? In the presence of KOH. So in the presence of KOH, so this is what it is Huffman bromamide reaction. It is Huffman bromamide reaction. So what will happen? Number of carbon atom, one carbon will be less. So what will happen? It will be NH2. So then answer is aniline. Understood? So we'll go for the next one. Amides can be converted into amines by, yes. So these are the following reactions. So which reaction can be applied for converting your amides to amines? Yes, Lohit Kumar, yes, it is D, right? It is D, Hoffman reaction. Hoffman reaction. So how CH3, CONH2, if it is what this, if this is your reactant in the presence of Br2 and KOH, what it yields you? CH3, CH3, NH2, CH3, NH2, right? Plus K2, CO3 plus KBr plus water. So this is what? This is your So this is your Hoffman bromamide reaction, right? So this is your Hoffman bromamide reaction. So amides can be converted into amines by Hoffman bromamide reaction. So which reaction sequence would be best to prepare 3-chloroaniline from benzene? So we have to follow some steps. Okay, and at last we have to prepare what? Our product of interest is 3-chloroaniline. Okay, 3-chloroaniline means our this should be, so this is aniline. So 1, 2, 3. So it should be 3-chloroaniline. So at last, so we have to follow such steps. Okay, and at last we have to get this particular product. So which will be the steps you're going to use? From benzene. Okay, you're going to prepare it from benzene. So benzene, you know, this is the structure of benzene. So benzene, first what you're going to do? Okay, I'll tell you. So benzene, first you're going to do nitration. Okay, nitration, HNO3 plus what? H2SO4. Okay, H2SO4. The temperature is 337 Kelvin. So this is your benzene. Benzene treated with nitrating agent. Nitrating reagent is what? HNO3 and H2SO4. Okay, so this is further what happens? Nitration occurs. So nitration is what? NO2, right? NO2. So this is what? Nitrobenzene. So this is nitrobenzene. So this nitrobenzene, further what you're going to do? If you do halogenation, okay, if you do halogenation, why? We want to, what? We want to form what? We want to, this is Cl, right? We want Cl. So with respect to your NO2, your Cl will be here. Okay. So now this is halogenation, right? So this is we have done here chlorination. So this is your chlorination. Next, what you're going to do? So NO2 groups can be reduced, right? It can be we can do a reduction. How we can do a reduction? By using tin and HCl. So NH2 and Cl. So what is the answer? So we have done nitration. Why we have done nitration? Because you know nitro groups can be easily reduced to your amines, right? And then we have followed by nitration. We have done chlorination. Why? Because our product of interest is 3-chloroaniline. So we want a substituted product, right? So we want a substituted product that is a chloro. Then we do reduction. We do reduction. So the answer is B. The answer is B. Okay. So most of you have answered it right. It is B. So we'll go for the next one. So we'll see the chemical properties. Okay. So next we'll see the chemical properties. Carbalamine reaction. Okay. Carbalamine reaction is a reaction in which primary amines. Okay, your primary amines is reacted with chloroform and alcoholic KOH. Okay, what you are going to do? Primary amine is treated with chloroform and alcoholic KOH. It is heated. Okay, it is heated to give you isocyanide or carbalamine. So this is a isocyanide. Okay, RNC. It is isocyanide bond. Okay, isocyanide plus 3 KCl and 3 water molecules. So this is carbalamine test. Carbalamine reaction, the reagents used are chloroform and potassium hydroxide. Okay, so the reaction goes like this. So this is the example. So aniline is taken, aryl amine is taken. So that is the aniline is treated with what? Chloroform and KOH. It is heated. Okay, it is heated. Your NH2 group is converted your NC. Okay, NH2 group is converted to NC, that is isocyanide. So it is phenyl isocyanide. So this is a carbalamine test. So this is a carbalamine test. So next we'll see reaction with acyl halide. So you know what is acyl halide, right? What is acyl halide? RC double bond O Cl, right? So this is acyl group. So this is the acyl group. So acyl halide, okay, this is a acyl group. So this is a acyl group. So primary amine is treated with what? It is treated with acyl halide to give you substituted amide. It is giving you a substituted amide plus HCl. Okay. So with amine, it yields you amide. Okay. So so next is reaction with nitrous acid. Okay, reaction with nitrous acid when you treat aniline. When you treat aniline in the presence of NaNO2 plus HCl. NaNO2 is what? NaNO2 sodium nitrate. Okay, it is a sodium nitrate solution. The temperature used is 0 to 5 degrees Celsius. Okay, 0 to 5 degrees Celsius. This is given in terms of Kelvin. So you yield what? You yield a benzene diazonium salt. Okay, you yield a benzene diazonium chloride. So it is N2Cl benzene diazonium chloride. So this reaction, okay, when you are treating your aniline with sodium nitrate plus HCl, Okay, at a cold condition of 0 to 5 degrees Celsius, you yield benzene diazonium chloride. This method or this reaction is known as diazotization. It is called as diazotization. Okay, so this is called as diazotization. So next, primary amine. Primary amine, if you treat it with nitrous acid, okay, if you treat it with nitrous acid, you yield alcohol plus N2, okay, N2 plus H2. So this is some of the chemical properties of your amine. So next is reactions of aniline, okay. So if you treat your aniline with NaNO2 and HCl, okay, what you yield? Benzene diazonium chloride. So this we have already seen. So when you treat it with NaNO2 plus HCl, you yield what? Benzene diazonium chloride. If you treat your aniline with bromine water, okay, if you treat it with bromine water, what you yield? Bromine water. What it gives you? It will give you 2, okay, 4, 6 tribromoaniline. So this is the product obtained with bromine water. If you treat it with concentrated H2SO4, you get sulfanic acid. Okay, you get sulfanic acid SO3, SO3H. Okay, SO3H. It is para directing group. So para directing, it will attach the para position. If you do oxidation with potassium dichromate, if you do oxidation with potassium dichromate, you yield para-benzoquinone. Okay, you yield para-benzoquinone. So these are some of the reactions, okay, of aniline. Next, we'll see questions. So the final product C obtained in the reaction. So they have given the reactant, they have given the reaction condition. So you have to go on finding which is A, B, and C. So they are interested in the C product. So just solve it. So first step is what? First step, they have done acetylation. Okay, they have done acetylation. So how you are going to do acetylation here? Acetylation, this is acetylation, right? This is called AC2O is nothing but you are doing acetylation. So what you yield here? So the first, okay, so this is your NHCH3. Okay, you treat it with AC2O. So this is acetylation. You yield what? If you do acetylation, you will yield NHCOCH3. Okay, amide. So NH. So this your COCH3. Acetylation means what? COCH3 group will get attached there. So your COCH3 group will get attached there. Okay, so this your methyl group will be as it is. So it will be as it is. So this is further treated with what? It is treated with Br2 in acetic acid. Okay, Br2 in acetic acid. It will, what will happen now? You're doing a bromination, right? So this will be remaining intact. So COCH3, COCH3. Okay, your so your CH3 and your Br. Okay, this is your Br. So your Br, so this is a compound A, this is compound B. Now further what you're going to do, you're going to do hydrolysis, that is H2O, H plus. So what you're going to obtain, you're going to obtain, so what you're going to do, this your amide group is converted into, after hydrolysis, into NH2. So this becomes NH2, Br and CH3. So the answer is what? So plus acetic acid. Okay. So answer is D, right? So the answer is D. Understood? So you're going to follow the reaction conditions. Okay, you're going to follow the reaction conditions. So this is with respect to your okay. So we'll go for the next question. Aniline on reaction with acetyl chloride. So I'll write the reaction, you tell me, then you will, after writing the reaction, you will understand. Okay, so this is your aniline. So aniline is treated with what? Aniline is treated with your acetyl fluoride. So CH3COCl. Yes, what will be the option? Yes. Yes. NHCOCH3. Yes. So the answer is C. So we'll go for the next one. Which of the following chemicals are used to manufacture of methyl isocyanate that caused Bhopal tragedy? Yes. Which is A is methylamines, B is phosgene, C is phosphine, D is dimethylamine. Yes, it is D, A plus B. Okay. So CH3NH2, that is methylamine, plus your phosgene, that is COCl2, gives you what? CH3NCO. Okay, CH3NCO. So it gives you CH3NCO. That is what? It is methyl isocyanate. Okay, it is methyl isocyanate. So the answer is a D. So answer is a D. So this is the methylamine and phosgene. Methylamine and phosgene together they form methyl isocyanate. So this is the gas which caused the Bhopal gas tragedy. Okay, so we'll go for the next one. A gaseous carbon compound is soluble in dilute HCl. The solution on treating with NaNO2 HCl gives off nitrogen, leaving behind a solution which gives smell of wood spirit. The carbon compound is. So it is CH3NH2. Okay, if you treat it with NaNO2 and HCl, it forms CH3OH. Okay, so it is methylamine. Okay, so methylamine. On heating benzylamine with chloroform and ethanoic KOH, product obtained is. Which is a product obtained on heating benzylamine with ethanoic KOH? Yes, I'll write the reaction benzylamine. Okay, benzylamine is like this, CH2 NH2, right? So this is benzylamine. What you're going to do? You're going to treat it with CHCl3 plus KOH. Yes, what you will yield? Yes, correct. It is benzyl isocyanate, right? So it is benzyl NH2 NC. Okay, so this is the product obtained. Correct. Okay, so this is the product obtained. So 3 KCl plus 3 H2O, right? So this is the correct answer. Good. So we'll go for the next questions. Amino group is orthopara directing for aromatic electrophilic substitution. On nitration of aniline, good amount of M-nitroaniline is obtained. This is due to what is the reason? What is the reason? Okay, so I'll tell you the answer. I'll tell you the answer. So the answer is B. Okay, NH2 becomes NH3 plus. Okay, which is meta-directing. Why? Because nitration involves what? Nitration involves acidic medium. Okay, because there is presence of acid, so it involves acidic medium. So protonation of aniline takes place, right? So protonation of aniline takes place, forming what? It forms an anilium ion. So what do you mean by anilium ion? Okay, NH3 plus. It is NH3 plus. So it forms an aniline ion in acidic medium. So which beings? So what happens? Which beings meta directing, and it forms meta nitroaniline. So it forms meta nitroaniline. So because of acidic medium, so NH3 plus. Okay, that is it forms aniline ion. Okay, it forms a anilium ion, and because of that, amine group is a what? Meta directing. So it will yield a major product in meta nitroaniline. Okay, so this is the answer. So we'll go for the next one. So in the reaction, so this is the reaction, you have to find the structure of the product T. What is the structure of the product T? Okay, so we'll solve this. So CH3, NH2, you are treating it what? NaOH and Br2, right? Hoffman bromamide reaction. So what you are going to yield first? CH3. Okay. There will be one carbon less. So this will become NH2, right? Correct? So this followed by what? Second step is you're going to add this particular compound. So that is double bond O Cl. Okay, what is this? This is benzoylation. You are doing benzoylation. Okay, you are doing benzoylation. What you will yield now? So the active site. Okay, the active site, this CO bond will get attached at NH. So it becomes a amide. So it becomes a amide. So you will get like this NH, C double bond O, and this is your, so this is your product. Okay, so this is your product. So the structure is this. Okay, the structure is this. So which is option A, B, C, D? You can see the options. Yes. So it is C, right? The answer is C. Right? Yes. So we'll go for the next one. I hope you have understood it. So we have done Hoffman bromamide reaction followed by benzoylation. Next is carbalamine reaction is used for the detection of. Yes. Where do you use carbalamine test? Where do we use carbalamine test? For what? For aliphatic secondary amines, aliphatic primary amines, aromatic primary amines, both aliphatic and aromatic primary amines. So it is used for both. Okay, it is used for both aliphatic and aromatic primary amines. It is used for both. Okay, it is used for both aliphatic and aromatic primary amines. Okay, so it is used for both. So in the diazotization, okay, in the diazotization of aryl amines with sodium nitrite and hydrochloric acid, an excess of hydrochloric acid is used primarily to. Why it is used? Read out the options. Why it is used? So it is used to suppress, okay, it is used to suppress the concentration of free aniline available for coupling. Okay, during diazotization of aryl amines, what happens? Approx 3 moles of acid per mole of amines are used. So to suppress the concentration of free aniline, which is free amine, which is available for coupling. Okay, so it is used to suppress. So the answer is to suppress the concentration of free amine. Okay. Next, what is the end product formed in the following sequence of operations? So yes, we'll solve this now. So C2H5NH2, you do HNO2. After using nitrous, what you get? You will yield what? alcohol, right? You yield alcohol. We have seen this chemical reaction, nitrous acid, it yields alcohol. Then this is treated further with what? PCl5. Okay, PCl5. So your OH group is replaced by your Cl. So it becomes C2H5Cl. Further, it is treated with what? NH3. So it becomes what? Your Cl. It is a good living group. So what it becomes? C2H5NH2, right? So the answer is what? Answer is C. Yes, answer is C. It is ethyl amine. Okay, it is ethyl amine. Yes, good. Okay, so we'll go for the next one. So next one, CH3, CH2Br. Okay, we'll solve this. So keep answering. So CH3, CH2Br, you're going to treat it with aqueous KOH and heat it. Okay, what do you obtain? OH. Br is a good living group, so it becomes CH3, CH2OH, right? OH. This becomes ethyl alcohol. So this is ethyl alcohol. So this is further treated with what? It is treated with KMnO4, that is a oxidizing agent. You are doing oxidation. So what of KMnO4, if you treat if you do oxidation with alcohol, you will yield what? CH3COH, right? You will yield a acid. You yield a acid. So this is a acetic acid. This is what? This is acetic acid. So further, what you're doing, you're going to treat it with ammonia. You're going to treat it with ammonia and heat it. So what happens? OH is a good living group. What you will yield? CH3CONH2. So it becomes a amide, acetamide. So it becomes a acetamide. So this acetamide, what you're going to do? You're alkali, bromine and alkali. You're doing what? You're doing Hofmann bromamide reaction, right? Hofmann bromamide reaction. What you will obtain is one carbon less. So it becomes CH3NH2. Understood? I hope you have understood. The answer is C. Yes. Understood. So follow the steps, and you will get the answer. Okay. So these are the way you are going to solve this particular question. So we'll go for the next one. I hope you have understood it. So next we'll see the reaction of diazotation salts. Okay. So this is what it is, diazonium salt. You know diazonium salt, you are going to treat with what? Hypophosphorus acid. So this is hypophosphorus acid. Okay, what you yield is benzene. You yield a benzene. Okay, you yield benzene plus N2 plus H2PO3 plus HCl. You're going to do a reduction using hypophosphorus acid with alcohol on benzenium salts. You yield what? Benzene again. So this is also a reduction. So if you treat it with boiling dilute H2SO4, you yield phenol. Okay, if you treat your benzene diazonium, okay, salt with boiling H2SO4, you yield phenol. Okay. Then if you treat it with cuprous chloride and HCl. So you know this is a Sand-Mears reaction. You yield what? Chlorobenzene. If you treat it with cuprous bromide and HBr, you yield what? Bromobenzene. So this is a Sand-Mears reaction. So we have seen the Sand-Mears reaction in alcohol phenols ethers, right? In phenol chapters, we have seen this. So next is when you treat your diazonium salt with copper in HCl, right? You yield what? Chlorobenzene. So again a Sand-Mears reaction. Then if you treat copper and HBr, okay, bromobenzene, this is also a Sand-Mears reaction. Then if you treat your diazonium salt with KCN or CuCN, okay, cuprous cyanide or copper powder, you yield cyanobenzene. Okay, cyanobenzene. If you treat your diazonium salt with potassium iodide and heat it, you formed iodobenzene. Okay, so these are, so with HbF4, okay, with HbF4, you will get your fluorobenzene. Okay, so these are some of the reactions with your diazonium salt. So these are different reagents, you will yield different products. Okay, so these are some of the chemical reactions with your diazonium salt. So in the reaction, so these are the reaction. So we'll see what is the product obtained. So aniline is taken. Yes, aniline is taken. Okay, aniline is taken. So this is aniline. You are going to treat it with NaNO2. Yes, if you treat it with NaNO2 in HCl, what you will get? You will get what? You will get a you will get what? N2Cl, right? You will get what? N2Cl. Then you are going to treat it with HBF4. Yes, HBF4. So if you get treated with HBF4, what you will get? You will get fluorobenzene, right? You will get fluorobenzene. So what is it? Benzene, diazonium chloride, and fluorobenzene. Understood? Okay, so we'll go for the next one. So this is a reaction. So nitrobenzene is there. So nitrobenzene, you are doing reduction with zinc, tin and HCl. What you will obtain? Yes, what you will obtain? Yes, it is NH2, aniline. Okay, correct. So X is your aniline. So I hope you have understood these reactions. So we'll solve next one. The correct sequence of reaction to be performed to convert benzene into meta-bromoaniline. Okay, what are the steps to be followed to be preparing your benzene into meta-bromoaniline? So first, so meta-bromoaniline. Okay, meta-bromoaniline means add this NH2. So what is the steps? What is the steps? Yes, correct. So we have seen this, right? We had prepared what? Meta-chloroaniline. So what? So you want so from benzene. So benzene, first you have to do nitration, right? First you have to do nitration. Nitration, you get NO2 group. NO2 group. Then what you have to do? You have to introduce your Br. So you have to do bromination followed by bromination. Then you have to reduce your nitro group. So how you'll do a reduction. So this is a D. Understood? So we have solved this question. We have converted benzene into what? Meta-chloroaniline, right? So the same way you are going to do this particular question. Aniline is reacted with bromine water and the resulting product is treated with an aqueous solution of sodium nitrate on presence of dilute HCl. The compound so formed is converted into tetrafluoroborate, which is subsequently heated dry. The final product is. So what is taken first? Aniline. Okay, so you have to write the reaction. Unless and until you write the reaction, you will not understand it. So aniline is there. So what you are going to do? You are treating it with bromine water. Okay, bromine water, you know what is the product form? So it will form what? It will form 2, 4, 6 tribromo. Tribromo aniline. So this is treated with what? This resulting product is treated with sodium nitrate. So it is NaNO2. Okay, NaNO2 in its presence of dilute HCl. So what you yield? So here what happens? It forms. So the remaining things here, it will be same. Okay, so this becomes N2Cl. So this becomes N2Cl. So this is further treated with tetrafluoroborate. Okay, tetra HBF4. So HBF4 in the presence of HCl. So this forms what? So this forms your N2BF4. Okay, N2BF4. Your NO2 group is been Cl group is replaced by BF4 group. Okay, and this becomes Br. This everything remains as same. Then further it is heated. Okay, this is heated. So after heating, what you will get? So your N2 group will be left and your BF3 group will be left. So what you yield is your F. So it is 2,4,6 tribromofluorobenzene. Okay, so it is 2,4,6 tribromofluorobenzene. So understood? So first what we have done, we have treated it with bromine water, right? We have treated it with bromine water followed by what? Followed by this what? Followed by you have treated with sodium nitrate in the presence of HCl. You yield your diazonium salt. This diazonium salt further treated with your tetrafluoroborate. So your N2Cl. Cl is replaced by BF4. So this is further heated dry. Okay, and you form 2,4,6 tribromofluorobenzene. Z. Okay. So Z in the following reaction is. So you have to tell what is Z in the following reaction. So C6H6. So this is benzene. Benzene is treated with this is a nitrating solution. Nitrating solution. So what will obtain? This will be your okay. Nitrating solution means what? You will yield your nitrobenzene. So nitrobenzene further treated with zinc and HCl. You will yield what? You will yield your NH2, right? You will yield NH2. This is reduction. You are going to do reduction with tin and HCl, right? So this tin and HCl, then this is further treated with what? NaNO2. NaNO2 and HCl means you are going to do what? You are going to do N2Cl, right? You are going to you get N2Cl. So this again further reaction you are going to do reduction. So on reduction with the hypophosphorus acid, what you will get? What you will get here? So this is reduction. So you will get benzene. You will get your benzene back plus N2 plus HCl. So B is the correct answer. Yes, most of you have answered it right. It is B. Okay, it is a B. Good. So what is the basic strength of amines? So because of the presence of lone pair of electrons, amines acts as Lewis base. Okay. So it has always a tendency to give a pair of electrons. So they act as a Lewis base. So aliphatic amines are stronger base than NH3. Because why? Because of the plus I effect. Okay. Then greater the number of alkyl groups attached to N atom, higher is the electron density on it and more will be the basicity. So the order of basic nature of amines is tertiary is more basic than secondary than primary. So this is the basicity of amines. Okay. So greater the number of alkyl groups attached to the nitrogen atom, higher will be the electron density on it. So as the number of alkyl groups are more on nitrogen atoms, so electron density will be also more and your basicity also will be more. So tertiary will be more basic than secondary and your primary. So this is the order. So aniline is weaker base than ammonia because the lone pair of electrons on nitrogen atoms of aniline is less available for protonation due to its involvement in conjugate ring system. So when you're talking about aniline, okay, aniline, so aniline and ammonia, what happens? Here, this is a weak base. Aniline is a weak base. Why it is weak base? Because the lone pair of electrons on nitrogen, okay, is less available for protonation. Why? Because this is involved in the conjugation with pi bond. So it undergoes a delocalization of electrons in the benzene ring. Okay, so it is a weaker base. Okay, it is a weaker base. So it is less available for protonation because the pair of electrons are involved in the conjugation of pi electrons in the benzene ring. So aniline is said to be a weaker base than your ammonia. So presence of electron withdrawing groups. So which are the electron withdrawing groups? So presence of electron withdrawing groups like NO2, then that is nitro group, cyanide group, and halide groups decreases the basic strength. So if your aniline is there and your nitro group is there, what will happen? Aniline is more basic, okay, than your nitro group because of the presence of this electron withdrawing groups, it will decrease the basic strength. And because and when your electron donating groups are there, like OCH3, okay, methoxy group, methyl group, okay, amine group, what it will do? It will increase the basic strength. Okay, it will increase the basic strength. So you can see here in this example, what happens here, methyl group is attached. So there is a methyl substituted aniline is present. So this is more basic. So because it is an electron donating group. So it is an electron donating group. So because of the presence of electron donating group to NH2 group, okay, it increases the basic strength. So as compared to aniline, this particular molecule, okay, it is more basic. Okay, it is more basic. So among the following, the strongest base is, yes, which is the strongest base among the following? Which is the strongest base among the following? So when we have said about nitro groups are, so this is forbidden. Then so the strongest base is D. Okay, it is a D. So see here, this is C6H5, comma, okay, it is comma C6H5 and CH2. So when you are talking, not C6H5, comma, it is. So it is like that, C6H5, CH2, NH2. Okay. So there is alkyl, okay, alkyl group is more as compared to here. So this is directly attached, right? This is directly attached. So this is directly attached. So here the number of alkyl group is more. So it is D. So D is the correct answer. The correct order of increasing basic strength in aqueous medium is. So when you're talking about basic strength, so they have given it like this here. So you can see here, right, R2 NH is greater than RNH2, that is secondary is greater than primary is greater than tertiary. And okay, so when you have CH3, when you have alkyl group, secondary is greater than primary is greater than tertiary, okay, and then ammonia. Then when you have a phenyl group, okay, that is C2H5, this is a ethyl group, right? This is a ethyl group. So when you have ethyl group, secondary is more than tertiary, tertiary is more than primary, primary is more than ammonia. Okay, so like this, based on this, you can answer this particular question. Yes. So the answer is, so this is CH3. So primary is greater than NH3 is less than your. Okay, this is this. So it will be C. When you are talking about secondary is greater than primary is greater than tertiary is greater than NH3. So this is given in less. So it is NH3 comes first, then your primary, and then comes your secondary, right? So it is NH3, then primary, and then secondary. So it is A. A is the correct answer. So which of the following is the strongest base? Yes, which of the following is the strongest base? Yes, A, right? A is the right answer. Okay, A is the right answer. Okay, so it is strongest base among these because lone pair of electrons is not involved in conjugation with the ring. Okay, it is not involved in the conjugation of the ring. So it is the strongest base among the following. Okay, so I hope you have understood today's section. I hope you have understood today's session. Okay, so we'll stop it for today. So we'll meet in the next class. Okay. Thank you. Yes.